So my name is Darin, and I have been a senior application engineer for GoEngineer for a few months now, but I have been in the SOLIDWORKS reseller community since 1997. And I've had the privilege of watching this product grow into the incredible ecosystem that it is today. And it is absolutely because of you, our customers. So I want to welcome you and thank you for that. Through my time here, I've created a few different things here. We do a lot of content here at GoEngineer, so you're going to see a lot more of that out there, and won a few contests. But what I'm really biggest into when I'm not working is really using SOLIDWORKS. When I'm not here, I use SOLIDWORKS more than when I am here. So I am a big fan of this product, really, whether I'm on the clock or not. A few summers ago, I built this beautiful treehouse and used weldment functionality, but with wood profiles. You get the same type of feedback with a nice cut list, but it's a great way to vet your project. Now I put a treehouse, it isn't really a good treehouse unless it's fully equipped with a garage door opener. So my daughters helped me do that last summer. Now all we have to do is hit a button and the trap door opens and closes. So some great things happening. And of course, I vet everything in SOLIDWORKS. It's just how I do things. So I'm a big fan of 3D printing. You're going to see a lot of that again on our YouTube channel. And whenever you get a chance, 3D printing is really a fantastic technology, and it's really just getting better. I saw my first 3D printer in 1989, and it was what sparked me to become an engineer in the first place. And to this day, I use mine at home often to repurpose things often. In this case, I wanted to go ahead and fit something that looked like it was meant to be on my boat. So I chopped up a trolling motor and really just repurposed it with a couple of nice parts that were designed in SOLIDWORKS. But through and through, I feel like SOLIDWORKS is the best way to utilize my skills and to teach my daughters how to really engineer things that they need and kind of control their own destiny. So join us on our YouTube channel. Come out and see us. We are the world's foremost authority when it comes to SOLIDWORKS content and knowledge. So please do visit us. So welcome to a fast-paced webinar on the best of what's new in SOLIDWORKS 2020. We're going to go pretty quickly. A lot of these things are going to be covered in more depth in a lot of the deep dive videos that we already have on our website. So feel free to check those out if you see something that you find interesting through my presentation today. We're going to stick to these three themes. SOLIDWORKS is always good about sticking to a particular topic. And we're using some files from one of our customers, Omax. They're an abrasive water jet cutting machine, and it's a really fantastic product, which really fits to a lot of the things that we're about to show. So we're going to start with improve performance. Now, the first thing is going to be detailing mode. This is something you're going to have to feel on your own systems to really get the idea. Because what's happening with detailing mode is we're opening up the drawing without even having to have the models or assemblies even resident. So it's different than the old detached drawings. You can take this drawing, you can send it to somebody in email, and they would be able to open it up in detailing mode and do 90% of what you would typically do. Add annotations, details, move things around, add things like that. So I'm going to show you a few that we can do right here. But the main thing you're going to have to feel is how quickly this happens on your own documents. So we're just going to do a basic file open here. I want you to see how fast this actually is. When we select our drawing, you're going to see a new mode selector here. This is part of the user interface, and it gives you an idea of what can happen in any one of these different modes and what's accessible. We're going to open this up in detailing mode and watch what happens here. This is a 5,500 part assembly. I just clicked open, and you can try to count, but it's only going to take about 5 seconds here for this thing to fully open. It's a pretty tremendous thing. All the line art is here. The assemblies aren't even resident in memory, so the math footprint is reduced incredibly. The tabs are all available to us, of course. But the main thing here is that we're going to be able to produce most of the things that need to happen when a drawing is being annotated. Now, you're going to need to have it fully resolved to do things like add a bill of materials and add views and sections. But once things are in place, everything that I'm showing you right now, I'm doing without the need to even have these models available. These views can be removed and moved. Annotations can be tweaked if necessary, as you can see. And then basic things like cut, copy, and paste are available here as well. Now we can add sheets and again do the 90th percentile of things that need to happen. Maybe paste this view back onto this sheet and put it wherever it needs to be, even reorganize things as necessary. The main part about this, though, is that it could be a lesser skilled or a lesser overhead employee taking care of these things that are really just the necessary things to get a project done. And when it comes to annotations, there's a lot of different ways to do these. Things that I like to show here, and just like anything else we do in SOLIDWORKS on the Windows interface, is going to be available based on whether these buttons are even available to you. So that's your first prompter of whether or not these functions are even available. So things like just adding annotations and doing these in our Smart Rapid Dimension mode is a pretty typical way. One of the things I like to show quite often with this is that there's functionality that a lot of users overlook, and that's things like these little dimension palettes. It's really easy to go ahead and add little annotations and tweaks, maybe add the word typical here, Oop, little fat finger there, excuse me. You know this is live. And there's other things that we've added too. Like in 2019, we took bill of materials, and if you selected them, you could make them all uppercase. Well, we've actually added that here to dimensions. So if you select it and say all uppercase, it wouldn't matter how the annotation was populated. It's going to take care of it and show it in a more appropriate manner. A couple of the other things I love to show are things like Format Painter. This is something that's been in the software for almost 20 years, but when you simply select an annotation and then click other annotations, it takes the format from the original source and simply pastes it to the rest of those. Really, really easy stuff. The main thing that I want to show you with this, though, is the fact that you can do almost anything here, even up to the point where you're going to save, and you still wouldn't need to have access to the files. Now, at this point, when you do go ahead and try and save this document, it is going to prompt you for a little bit about what's going on. And if you feel the need to, you could resolve this at this point, but there is the ability to save without resolving. Now, in my particular case, we're going to go ahead and save without resolving, but we're going to do what is typically done with these large assembly drawings. And that's not necessarily saved as a SOLIDWORKS file, but saved as a PDF or a DXF or a DWG. Because the line art's resident, we can do this. Now, when I go ahead and save this particular document, what we're going to see is just how pristine the line art is. Really, that's the main thing that's there, but it's the rapid, most common operation here with these really large drawings. Now that popped up over on my other monitor here, so let me pop this over. But you can see very cleanly that all the drawings look there, the revision clouds I placed are there. Really fantastic functionality. So do this on files that you're intimate with. You're only really going to feel the functionality when you open up a large assembly that you yourself have struggled with waiting for the drawing to open up, and in many cases, again, just for these lower level functionality and tasks. One of my favorites, though, without a doubt. Now we're going to move to envelopes. This is an interesting functionality because it has to do with external relationships and how parts interact with other parts within an assembly. So with the topic of external relationships, there's functionality under Tools and Options, your gear icon up at the top. And that enables you to go ahead and actually control when and where somebody can add a relationship. So in some cases, people get top-down relationships accidentally because they edit a sketch and accidentally drag it to an edge of a part, creating a coincidence. Well, this enables or disables the ability to have it happen outside of an envelope functionality, which I'm going to show you now, or within the top-level assembly, and maybe only allowing it at the same sub-assembly level. So greater control over where those external relationships can even proactively or accidentally be applied. Now when it comes to envelopes, I want to show this to you live in a couple of different ways. And I got to set this up a little bit using my OMAX machine. Envelopes usually are some particular area. They represent an area that's either a keep out area, a work zone, maybe in a reach study. And in our particular case, what an envelope is going to represent is the cross-pollination, if you will, of data from one file to another in order to create more appropriate links in the file in which those relationships or references should take place. And I'm going to do that right now by opening up a couple of parts here. So we've got some plumbing that I've just opened, and we've also got a bracket. And what I want to do is open up the bed assembly in this OMAX abrasive water jet just to give you a little context of what we're talking about. Now you see the plumbing hanging right off to the right-hand side. The bracket that I opened is actually part of the subassembly you see in the middle. And for the sake of proper compartmentalization, this is the proper way to set this assembly up. But at the top level assembly, this head and this plumbing assembly need to interact with each other. And this is where a lot of overhead on the system takes place, and frankly it just becomes a more difficult operation because now I have to turn this into a flexible subassembly, and now we have mates solving at the top level as well. Well, we can absolve this of all of that overhead by using envelopes. Let me show you what this does. So to remind you, back here we have our plumbing subassembly, and all it is just piping and fittings. Well, back here at the top level assembly, I have a bracket right here in the middle, and I need my plumbing to interact with that. So we use this button at the top called Envelope Publisher. Now when you select it, the interface here is real simple. We're picking the components that we want to push down into other subassemblies. Doesn't matter where they reside, but we're going to push those references into the other subassemblies. So I'm going to pick this bracket. Then we select the subassembly or assemblies that we want to do this in, and it could be multiple simultaneously. For our sake right here, what I'm going to do is just select from the featured tree so it's real clear to you. We're going to put this into this scissors assembly. And when you click Add Group, this is an opportunity for you to do this over and over with different references before exiting the tool. Groups are used in a lot of different places. So once this is done, it creates the group. And what it effectively does is it creates a reference from the central assembly, from that head assembly, over to the plumbing assembly. Let me show you how this plays out. So once we go ahead and say OK to this, I'm going to toggle back over to my plumbing assembly. Take a look at this. What we now have is a transparent representation and an envelope folder here containing these that shows us the exact position of this part in the other subassembly at the top level where that envelope was created. The purpose here is that I can now create the reference to that part here at the subassembly. So here we can easily go ahead and put an edge selection, maybe grab our plumbing. Let's just go ahead and use a little profile center mate. Now the parts can move because of course the mates solve here. And because we're referencing that part now here at this subassembly, as we toggle back over to the top level assembly, our plumbing is going to be in the proper position. Now the reference didn't have to take place at the top level assembly. It's the way the envelope pushes down. Now if this head assembly ever moves, the bracket moves, of course the reference in this scissor subassembly is going to have to move as well. So it's a great effective way to make this happen. Now we have a limited time here today, but I want to show you a second example of this because I think this captures maybe more of what a lot of you might do out there. This assembly I've been using since 1998, so it's officially, at least in Michigan, old enough to purchase alcohol. But what I have happening as context here is we have a subassembly of an assembly line. And in this particular area we have a press which happens to be floating in the middle of space with a stand that's yet to be generated. If we open this press in its own window, of course those are old files, you can see that again it's just floating in its own window. So back at the top level assembly, I'm going to use the envelope publisher to push the floor from whichever subassembly or level of the assembly it's in down into the press assembly. Simple. I could press all the assemblies after I wanted to and put that floor in them all simultaneously. When we toggle back over to the press subassembly, you're going to see now that we have that reference down there. And now real easily, all I actually have to do is create a basic feature. Here we're going to go ahead and put in a sketch. We're going to do some offset entities, which is going to be real quick. And then I want to just go ahead and create a nice extrusion here. So again, basic features. We're going to extrude this, double clicking our face up to surface. So there we have it. We have a feature that's now referencing the floor in this assembly. Now when you go back to the top level assembly, this is why I wanted to show you this. We're going to make a change now that changes the floor. And as you do this, it's going to reveal the fact that the floor is actually concealing that little envelope graphically. Now, of course, if the floor moves, the envelope created from it moves, which means all of our references update. Here's a little rebuild, and there you go. So I think it's fantastic functionality. It will definitely enable or promote performance because it won't require you to have to do as much flexible subassembly capabilities at that top level assembly. Really, really great stuff though. Okay, let's keep moving here. So we're going to get into this next one here, flexible components. And this is going to be the last of the ones that are really, really detailed demonstration live for you. Because this one here is really awesome, but I feel that you need to know how it's set up. Because what it's set to do is turn a part that's rigid, which all of our parts are built as rigid nominal parts, and it turns it into a part that will now flex and move much like a spring or a boot would based on some part references. But what we're really doing is we're remapping some external references. What that actually means is that we have to create those external references to begin with in order to be able to remap. And that's where I want to show you where this thing works. So let's go back into SOLIDWORKS here. And again, we've got some really great videos online that take a look at this. I did a top 5 video that's on our webpage as well that really explains this out. So I've got 2 different assemblies that I want to open here for you just to give you the context. So these are the sample files that actually install with SOLIDWORKS 2020, so you can try these yourself if you'd like. What we've done over in the right-hand assembly is we've created a spring, and the spring's functionality rebuilds or updates when we change where this blue part happens to be. Now we do this in user groups and in videos all the time to show you how you can have a sketch reference for a sweep down the middle, and that sketch referencing the blue part and the red part. And as the blue part changes, then the length of the red part, the sketch line changes, which then updates the spring. So there's ways that you can search out how to set this up. The main thing that's happening here though is that the spring has a top-down relationship in the form of a plane, and that plane is simply coincident to the bottom blue part for this example. So in this assembly, we've generated this relationship so that if the blue part moves, the plane moves, therefore your spring compresses or extends. That's something that people have been able to do for a long time, but this is where it always falls apart. What I want to do now is use that spring in another subassembly. And that's where that will then give you an error in previous releases of SOLIDWORKS that says this part has top-down relationships created in another assembly. Well, now we're going to allow us to reassociate that relationship to this part. So as we do that, we're going to do it really simply. There happens to be an axis down the middle of this part, and we're just going to mate these parts up so we can locate them. Okay, easy enough. And then down here at the bottom, we've just got a simple ground face. and that's going to be coincident to this top part. All right, so nothing mystical there. What we've generated now is a part coincident to a part. So as we move it, they move. Here's the magic. Pick on the spring and now click this button here called Make Part Flexible. Once we do, it then reveals that top-down relationship that we designed over in this seed subassembly and allows us to re-reference it in this assembly by simply picking a face. What we've now done is we've repurposed that part and turned it into a part that as it moves is going to automatically update and expand or compress. Now if you thought that was cool, it gets better. I'm going to do a second instance of this part, and you'll notice that each of those instances, though they would show up as a quantity of 2 on the bill of materials, can have completely independent extension or compression positions because each of them can be an independent flexible part with different relations. What that translates to is this one spring could be used everywhere in an assembly it needs to be and be in a completely different state of flex based on this functionality. It is tremendous. So we set up the seed, not difficult to do, and then really the world's your oyster in how we can make that happen within any subassembly you'd like to consume it in. So I really love that functionality. Seek that out on our webpage again if you want to see that in a little bit more detail. All right, moving forward. So assembly mates. I think we've been doing mates for 20 years that we wouldn't have much more we could add to this. But I got to tell you, I've been using SOLIDWORKS 2020 for about 6 months now, and I went back to 2019 for a previous project. And this one threw me for a loop because of the things that I had in 2020 that I now really wished I had in previous releases. Those are things like being able to use the Quick Mate toolbar with more rich access. So in this particular case, if you pick 2 flat faces, you're going to get additional distance limit and angle limit mate capabilities on the Quick Mate toolbar. Now the slot mate also comes up if you pick slot geometry and some other circular or cylindrical face. But on top of that, once you select the slot, it's going to then prompt you for the granular details of the position, whether it's centered or free within that slot. Same with the width mate. You're going to be able to select 4 faces, pick the width mate, and then it's going to give you the fine-tuning details available. What's also great is that with all of these, it's also going to automatically pop up a flip mate alignment button. So you don't have to do that little tweak to a part and roll it around. So when you want to put 2 faces coincident, they're going to be closer to the coincidency of the face alignment. Just put it on and you'll immediately be able to realign if it's the opposite of what you need. No tweaking necessary. And then all of that with the width mate, you can right-click its mate in the feature tree or on the breadcrumbs and access flip mate alignment as well. You actually had to edit the width mate to be able to flip the mate alignment in previous releases. So great stuff with those. When it comes to assembly patterns, mirrors and patterns are the same things. Now with patterns, we did some things with 3D patterns, and most importantly 3D hole wizard patterns. Because when you do a 3D hole wizard pattern, faces or features and holes can be opposing in position. Well, our pattern-driven patterns, which would be a fastener pattern into those 3D holes, will now honor the orientation of all of those holes wherever they happen to be throughout the assembly, as opposed to aligning to the seed. What I wanted to show you on this one had to do a little bit more with mirroring. Now with mirroring, what we're doing here is giving you a more rich user experience. First of all, when we go ahead and do mirror of components around a plane, we're going to have some capabilities to position that's a little bit more obvious, but we've added a new one here. Prior to this, we used to only have center to bounding box or center of mass, but the component origin for parts that are non-symmetrical was always the better option, so we finally added that. You can see that's a very, very small distance. And then the buttons for orientation, they're a little bit more obvious just because of the way that the icons have been positioned. So not earth-shattering, but I've gotten a lot of reactions to this through the live road shows, just simply because of how the users felt about some of these things that are more annoying than anything that have now been addressed. Markup is something that we introduced in SOLIDWORKS 2019, and for me, I thought it was great, but it had 2 major flaws. Number one, it relied on a touchscreen computer, which, you know, I didn't have a touchscreen, so I guess I was a little jealous. But number two, it only worked in parts and assemblies, which was great, but traditionally, red pencil lineup happens on a 2D drawing. So that's where we've gone with this with SOLIDWORKS 2020. Now I can't demonstrate this for you, so I'm going to use a little demo magic and have some inset window with one of my friends here who used his touchscreen to do this for me. So what he's doing is just simply showing you that there's a pencil tablet. This could be a Wacom tablet, this could be any computer that comes with a touchscreen. Really a lot of ways to deal with this. But of course they're simply orienting and putting notes on the 3D assembly. Now in this case it actually stores each of these positions in a folder in the feature tree. You can easily preview those. You can also easily reorient to see those because of course the orientation that the note was placed on it is really pertinent to what that note means. Now, when all is said and done, you can take those notes and save them out as common image files, things like just JPEG and PNGs, or a PDF file if necessary. But the real magic to this now is that we can now do this not just with a pen, but now we can actually do this with your mouse and on a 2D drawing. So both of those. So the 2D drawing, again, more traditional. We're going to put those notes in, and in the same way, we're going to store them in a folder in that feature manager. Now, this is going to live with the document. So when you send it to anybody, whether they have a touch screen or not, they're still going to be able to consume this. And whenever they've addressed whatever that note depicts, they can easily just hide it. So that allows us to really keep the communication on the drawing where it's meant to be. But again, you're not left out if you've just got a regular mouse. So in this case, we can go ahead and click the markup and pick our color and thickness of our lines, and then again, just simply sketch directly on the drawing. So really, really great enhancements this year. They were the first 2 enhancement requests that I put in last year, and I'm really glad to see that those were taken care of. So mouse support and 2D drawings. Okay, so have you ever had a broken fillet? Now, it's really a rhetorical question because you haven't really used SOLIDWORKS unless you've had a broken fillet. So we've got a way to now repair these missing fillets automatically. What's interesting about this is that it allows you to anticipate this a little bit if you know what you're working with. And again, I feel it's really necessary to demo this live because you need to see the workflow that leads up to this. Now, this is something that happens to all of us. We have a design change that happens because of a reason, but we don't want to be penalized for that reason any more than we have to. So in this particular part here, we have this filter plate. Now, for the sake of configuration, we might have one of these that has these holes in it and one that doesn't. So what we're going to do is roll back a little bit beyond our fillet and our hole. We're just going to make a small change. Now, to do this, I'm going to edit the feature, but I'm going to use a little contour select, and we're just going to use the outside. By the way, if you ever participate in Model Mania, brush up on contour select. Definitely necessary. So with this, we go ahead and select that same sketch. I'm going to use it again, and I'm going to use that sketch now to create a second feature of a cut. The purpose of this simply being is that now I don't have to, have 2 different parts here. What I can do here is just simply have one part with multiple configurations. Oop, didn't quite work that. Let's hit that one a through all. How about that? Yeah, it's a little better. Okay. Now, as we go ahead and start to roll back down, my holes are going to update because they're related to the sketch, but alas, all of my fillets are broken. Now here's where a right click is going to save you. Say right click, edit feature, and it will show you, just like we have before, the missing edges and then all the dead silhouettes on screen of where those fillets used to be. The fix now, though, is you right click them and say repair all missing fillets. Magically reattaches those. Now with that, I got to tell you, it won't work if those edges aren't in the same position. So if you do happen to change the offset thickness here, change it to make the cut. Then update your fillets and then change the offset distance of that sketch because it will repair them, and then once they're reattached you can do just regular SOLIDWORKS associativity. So very important that you do that in the right order. It's not magic, it's not going to find those edges if they move, but if you know how to work that, then you know that you want to do it in a particular order before you actually go through the process of editing any other features. Surfacing has a very similar thing. Now, I've always had problems with, and so has everybody else, with the offset surface tool. So again, I want to demo this one live just to show you some of the things that we've dealt with. Now, I've gotten the most customer reaction from this one live as well. When we're offsetting surfaces, a lot of times we have these internal features here that collapse back on themselves. And if you've done this long enough, you anticipate that, but it doesn't make it any easier to deal with. So here with our surface tool, what I want to do is just take this entire surface, and we're just going to do an offset. Little bonus here, we don't have a copy surface tool, but if you set this to 0, you'll notice that that actually says copy surface. Kind of cool. For our purposes though, we're going to bump that up to 5 millimeters. So I got a good preview out here, and of course, as you know, anytime you have a preview, you're guaranteed to get good results, right? Well, not with surfaces. In this case, the offset creates self-intersecting geometry, and this is usually where you're manually stuck trying to deselect and filter out the features that failed. Not anymore. It's going to identify the failed faces, which is part of the problem, and then you can now right-click and remove just the failing faces, keeping just the good ones. That'll allow you to go ahead and create the offset and then deal with whatever little idiosyncrasies and edge overlaps you might have after the fact there. So that's the kind of thing that's really going to save a lot of time when it comes to generating these types of offsets and then being able to just deal with simple trims and extends in order to clean that up. Great stuff though. Okay, so last couple of things I want to get into here. Drawings are pretty important. Everybody does drawings still. Some of the things I want to show you here is that tools and options. You can also set uppercase for the dimensions and hole callouts just as a default feature. So uppercase for anything. And that's saved with your document. So it's actually saved in your templates. Important thing to know there. And then some things that you can do with alternate position and drawing scale. There is a file called the drawing scale.txt file. And it's just like your whole call format txt file, where you can customize what scales actually show up in the lower right-hand corner of your drawing sheets for the scale changer. So a couple great ones there. I don't want to get deep into structure system. We have a really detailed deep dive on this. What I want to show you though is that it's really just more of an append to the way that you do weldments today, but it doesn't rely on the 2D and 3D sketch framework like it did in previous weldments. Structure system, the one you're seeing here, was actually generated by using this as the starting sketch feature. So it's tremendous what you can create based on not having to rely on a framework that's built of those 2D and 3D sketches. So again, if you're big into making really large format welded systems, you want to check out our video on structure system and see how the details of this work, because it really could be the thing that you've never known you've always wanted. So please check that out. All right, last couple of things and then we're going to wrap up here. Now I told you I'm a big fan of 3D printing. 3D printing is basically like 2D printing now in SOLIDWORKS. When you're sitting in the SOLIDWORKS interface, and I'm just going to show you this briefly, you're basically picking a printer just like you would a regular 2D print. Now, we've had File 3D print inside of SOLIDWORKS for quite some time, but what it triggers now is the access to the printers over on the right-hand side. And when you pick the type of printer that you have here, what it's actually going to do is show you exactly what the build chamber happens to be and whether your print fits inside there. There are automated ways to fit it, both up to the build chamber and to orient to fit within the cube. And it's going to give you a lot of previews for things like your striations and your slices. And all of these things get baked into this new 3MF file, which basically is a file that contains all of the individual 3D print data here just through a simple file save as. Now it's meant to be a black box file, so when you go ahead and save this 3MF, what you're also saving are things like the striations, the type of material, and temperatures and other details when it comes to what's included there. This is theoretically supposed to go to any 3D printer and go ahead and print without the need for a pre-slicer. Really great stuff there. All right, last two pieces I'm getting into are kind of peripheral. 3D printing, we've got a mechanism that also allows you within our task pane to connect to the 3D Experience Marketplace. And in this case, access people with 3D printers if you don't have your own. So plenty of people out there have themselves registered here as service providers. You simply pick the type of process, the type of material, maybe the expense you're looking to adhere to, and then it's going to go ahead and connect you with contractors out there that can send your part to you really as rapidly as overnight. So it's really a great service, but it connects people who don't have manufacturing and fabrication capabilities to those who do. So check that out. It's going to be in your right-hand tab there in your task pane. Last two things I want to hit here have to do with a little bit more of our augmented and virtual reality pushes. And the first one here is actually with EDRAWINGS. The performance of EDRAWINGS is ridiculous. You have to open up these files and see what it looks like on your own system. But what I can show you here on this one is when I go ahead and open up EDRAWINGS, I'm going to go ahead and do some augmented and virtual reality, which is no longer beta in this release. If you simply say File in SOLIDWORKS and EDRAWINGS 2020, you're going to see Open in VR. And to do this, you don't have to make some other type of file. You're just opening up normal SOLIDWORKS assemblies. Now this is great for large assemblies that you want to show customers what they look like, or things that are going to be only one-offs, like large observatories that we did last year, where you really don't have an opportunity to make a prototype, and you still have to be able to show people what it's like to work inside that environment before fabrication takes place. Well, here EDRAWINGS is giving us some incredible graphics. And you'll see here that as we're looking at this, we're basically getting, there we go. We're looking at some incredible graphics here, and it's starting to understand things like depth. So as we zoom into something and we get through the glass, it'll change the graphics and really change the user experience at this point. But we have a lot of capabilities to be able to walk around this. I'm only using this on a regular SOLIDWORKS system, and I don't have access to the augmented reality tools that I'm about to show you. But with $500 on eBay, you can get an HTC Vive headset and basically immerse yourself in any SOLIDWORKS assembly. So what we have here is the headset and then the handheld platens that allow you to walk through and interact with things. Touch things, click on them, point, grab them, do different things with them. So it's a great way to be able to, again, immerse yourself into a virtual model that's never going to be made more than once, but still be able to validate it before it actually goes into production. So I love that. All right, last thing I got to show you is SOLIDWORKS Sell. Now, SOLIDWORKS Sell is not part of the core SOLIDWORKS product. So if you're interested in this, it's something that we're going to want to have a conversation about. But because it is brand new, I felt it was necessary to show this to you. SOLIDWORKS Sell is a configurator. And a lot of you have been asking for this, and usually these things are really difficult to deal with, which is why I'm so excited to show you this. This 3D configurator will create millions upon millions of iterations just by creating the permutations due to your input. Now, we've used this with the OMAX assembly, and here is it live on a website. So you give opportunities for users to come to your page and really configure things in any way that you want. It could be materials, it could be positions or configurations, as we're showing here with doors open and closed. There's a lot of different ways that we can deploy this. What's interesting about it is the performance is tremendous, first of all. But what also happens with it is that there's the ability to deploy this through a web page on devices like tablets and smartphones. So here when we're looking at in just a regular computer's web interface, it's not going to be quite as dynamic. But if we open this up on an iPhone, what you're going to see is the ability to actually go augmented reality. Now, virtual reality is completely fake. You have a headset on and you're seeing nothing but generated stuff. Augmented reality is putting fake inside of the real environment. Now, I'm showing this to you right now on this video here, but what I want to do is actually use my Zoom meeting here to show you something pretty nifty. So what I'm going to do with the Zoom meeting, if you'll bear with me for a second, is I'm going to do a new share, and I'm actually going to show you my iPhone live as I do this. That's the first time I've done this, so please bear with me. So we click this over to AirPlay, and what it's going to do now is show you on the meeting exactly what my iPhone sees. All right, that's working pretty good. Now, when I'm going into Safari in this particular case, what I'm showing you is a web page that is our GoEngineer.SolidWorks Sell site, and you can go ahead and check this out when we're all said and done. The main thing I want you to see here is that in the corner of the page on a tablet or a phone, you're going to see this icon here, which is the augmented reality. And as I click on that, it gives me the opportunity to roll my part around, and one more time, lower right-hand corner, you see augmented reality. Now, as I click that, I can still roll the part on my screen, but if I click AR, then that triggers my camera. And just so you know, this is absolutely live. I'm sitting here talking to you on my camera right now. Now, all I have to do is point my phone at a horizontal surface, and once it picks up the horizontal surface, we'll move this right over, and there we go. What we now have is a speaker sitting right here on my desk, and it finds the horizontal surface, and it sits right here inside my reality. So again, I'm sitting right here, and there you go. So it's an amazing thing to be able to put your assemblies at a one-to-one scale. What's basically happening with them is they'll jump in, they detect things like floors. So if you want to see a larger model on the floor, then that's something that you can go ahead and do as well. Now, if you go to our website, you can do this even right now. It is goengineer.com/AR, as you can see on the screen right now, and the lower left-hand corner of the slide when it comes back up. But what you see on this is a page where you can grab any one of these. So if I go ahead and grab the chair here, you're going to see that this is the opportunity that you can do. These are directly on our website right now, so if you want to go ahead and grab one, you'll see the chair. Upper left-hand corner, you see the AR button. And again, if I hit AR one more time, this is the opportunity to go ahead and throw this on the floor of my office as well. So there we go. And we'll scale that down to 100%. And there it is, sitting in the corner of my office. So pretty crazy stuff that we're able to do using SOLIDWORKS Sell. All right, let's go back and get our share back to where we should be. So that's an interesting thing that we can do with these particular tools. Get a hold of us. All of the AEs at GoEngineer, we've done a lot with trying to play with this and get ourselves skilled up. So I've got a lot of example models that I can show you out there, including the treehouse that you saw in my initial slide. So get a hold of us, and we'll let you know what it takes to make all of that happen. So once again, I want to thank you for the time that you've spent going through this with us today. We have a lot more detail again on our webpage, so I want you to check that out. You can spend a little bit more time trying it while you have the videos playing side by side as well. Also, if you want to get informed about any of the content that we're creating or what's going on with GoEngineer, hit us up on social media, whether it's through our website or our Facebook or Twitter page. I'm on LinkedIn quite often as well. And when I'm announcing things or putting things out like videos or these types of webinars, I'm putting those out on Twitter as well. So just follow me on Twitter at GoWithDarin. So again, we're recording this. If anybody that you know would like to see this, it'll be up on our page here pretty soon. And you can go ahead and check it out again when you're ready to try these things out live. So let's go ahead and take a look here just before we adjourn, just what kind of questions might be going on, just to see if anybody's got any out there. It doesn't look like anybody's asking anything, so hopefully we've answered everything quite sufficiently. If you do need to get a hold of us for any reason, you can email me directly if you'd like, dgrosser@goengineer.com. And with that, I'm going to go ahead and again, thank you for spending a half an hour with us today. I hope it was worth your time. We really strive hard to make sure that, that your attendance is worth it to it. So thank you once again. Have a great afternoon. Take care.